Welcome, Mindsetters, to this fantastic show, Learn Extra Live, here on a Wednesday. This is the only show, grade 10s, where we have two women, I know, on a Wednesday. So strange. Cheryl, how have you been?
I'm very well. Just feel the intelligence in the room when there's two women
so
here.
smart.
Hey?
And it's Women's Month, can you believe
Yeah.
it? So I just want to tell you where to get all the information before. Okay, well, Cheryl, do you want to say what we're doing first?
No, we're just going to be looking at ecosystems, carrying on with our ecology section.
Okay.
And you give them the information and we can start.
Okay, perfect. Well, let me just tell you where to find me on the Facebook page, and that's facebook.com/Learn Extra, or all the notes that we'll be doing right now on ecosystems will be available on mindset.co.za/Learn Extra. And extras with an X, just in case you're wondering. I just want to give a shout out to my friend all the way in England, Blake, and I hope you enjoy the movies. He told me he's going to the movies now. But grade 10s, if you want me to give you a shout out, talk to me on Facebook. We want lots of questions today, and I think we should get the show started. Let's go, Cheryl.
Thanks, Megan. Welcome everybody to another Wednesday. All right, grade 10s, I hope you're enjoying this section of work, the ecology section. Sometimes everybody goes, oh, it's a boring section, but it's a nice section because it's quite easy, because if you look at things around you, and it's very much things that you can see and that you actually do know about, but you sometimes not quite sure where it fits in. We're going to be looking at ecosystems, carrying on from our section from last week, where we're looking at the environment. We're going to touch on, all right, two words that we did a lot of last week, the biotic and the abiotic. And last time when we were looking at them, we mentioned the biotic and the abiotic. This time we're actually going to look at the particular characteristics or the particular organisms or climatic features that make up the biotic and the abiotic. But when we come to this section, you need to pay particular attention to the terminology, right? Very often when we talk, you need to be able to say the words, to know the words, all right, and know the definitions. That is very important. So as I said, biology is a different language. You need to be able to become comfortable using those terms. We're going to start off with defining our very first, the word that we started off with, the ecosystem, okay? And an ecosystem is the interaction. I always keep using this word because we used it a lot when we looked at the biosphere, is the interaction between my living, biotic components, and my non-living, my abiotic components, all right? And we started to look at last week, we started to say things about that the abiotic, my non-living, are going to have an effect on my living, right? And today when we look at that, we're going to see much clearer what we mean about that. So an ecosystem, all right, has the non-living and the living, and they all interact. They depend on each other. The biotic depends far more on the abiotic, but they are going to influence each other. All right? And very importantly, as I say to you, one is going to have an effect. So it's the interaction. Okay, let's start off with our first section. Okay, we're going to look at, as I said, when we look at abiotic, you know I like to use pictures. All right? So I've put a very, very simple picture here. All right, the little pond. And this is what we call, this is an ecosystem. An ecosystem doesn't have a predetermined size. It can be as big as a rainforest and as small as a little puddle of water, all right? Because we're going to find both the living and the non-living, the abiotic and the biotic factors. So if we look at this picture over here, what do we see? I see a frog, I see a tadpole, a fly, I see a water beetle, a snail, and a fish, and I can assume, all right, that those are going to be my biotic components. Those are my living. Then I see that there's water, there's some wood over here, that would also be the living. Water, oh look, there's the sun, all right, and those are not living. So those are going to be part of my abiotic characteristics. Have a look at a different one, okay? Again, what do I see? I see animals, I see seaweed, sea plants. Those are living things. But what are they in? Again, there's water, there's land, there's soil. So have a picture in your mind of an area and start being able to identify, okay, that's an abiotic, that's a biotic. So you're able to get that concept into your mind. Okay, we're going to start off with looking at the abiotic factors. All right, the abiotic factors are, as I said, the non-living. And we're going to look at three things. The first one are the physical characteristics or the physical factors. Light, which is sunlight, temperature, water, atmospheric gases, wind, and fire. We're not going to look too much at fire, but we're going to be looking at the rest. Then a new term for you, and again, as I said, terminology is very important, is physiographic. All right? Physiographic factors. And I'm going to explain it when we get much closer to that. That's going to be aspect, slope, and altitude. Right, if you do have the notes, you'll also notice that there's a question that I've put at the end that you can use to practice that. Then the last section that we look at is edaphic factors. And edaphic quite simply means soil. But again, it's a different term for soil. And when we look at the soil, we're going to look at, does pH play a role? The humus content, all right, the texture, how much water it holds, how much air is in it. Because all of that is going to have an effect of what grows in it. Okay, so let's start with our first one, our physical factors. Now I want you to think, first of all right, sunlight, light intensity. Now you're going to see what I've done is I've put certain terms that you need to be able to not only define, but also will help you to understand. Okay, the first one is sunlight is essential for photosynthesis. If we don't have sun, all right, plants cannot make their food. Right, photosynthesis will come up often here. All right, because photosynthesis, you need carbon dioxide, right, and you need sunlight, and you need water. All of those are abiotic factors. So for plants to make the food, right, they need a lot of abiotic factors. So for starters, all green plants need sunlight, right, for photosynthesis. And they're going to use the sunlight during the day to make the food, and then they store it at night. Okay, the next word is a new word. Okay. There are two, phototropism is more this picture, all right, over here. Let me get my thing going correctly. Is that phototropism, and I'm going to write it, is the movement of plants towards the sun. Plants, the stems of plants, what we call are positively, look at the word again. You're going to see the word photo comes up a lot. All right, photo, remember, means light. When we did photosynthesis, light makes something. Okay, phototropism, plants grow towards the light. And here I've got I don't like broccoli, all right, but here I've got a little picture of it, and that's what it's doing. Plants will grow towards the light, and that's why plants usually grow upwards, okay, because the sun up in the sky, and they want to reach the maximum sunlight because they want to photosynthesize. So what do? They grow towards the sun. They make sure that their leaves are in such a way that it is facing the sun. All right, so that they are able to photosynthesize and obviously make the food, and the most important thing, the oxygen. Next word, so we've done photosynthesis, phototropism, and the next one is photoperiodism. Now, if you have a look at the picture, what photoperiodism means is basically the length of a day. So some plants, all right, see if you can get what we're looking at here. Some plants are long day plants. They need 12 hours of sunlight. And some are short day plants, right? They need less than 12 hours. So now, can we start all those cogs in our brain? Are they clicking over and thinking, okay, when is daylight longer and when is daylight shorter? Okay, yes, seasons. All right, the different seasons. So here we're going to have the seasons. So certain plants that are they need long hours of sunlight are going to obviously grow in the summer. Plants that only need a shorter period of time, they are going to be your winter plants. Okay, so it's not only the cold that has an effect, the temperature as we look, but it's the actual length of the day. So our short day plants, we're going to find those in winter, all right, and then our long day plants, we're going to find that they're going to be more prevalent in summer. Photoperiodism, what is a period? A time, a limit of time. Okay, so those are the more difficult ones. Now we get into terms that you should, all right, let's start again, you should know by now, but if you don't, light. Light is a factor here, all right? So some organisms are nocturnal, right? What does nocturnal mean? They are active at night. And it could be for various reasons, okay? If you have a look at, put a picture of an owl here, it's going to be adapted to hunting at night. It's got these huge big eyes, all right, they can see better. Its neck can turn in various ways. And why do you think it's nocturnal? Quite simply, there could be a lot of reasons why animals are nocturnal. It could be cooler. Their prey could be nocturnal. There could be less competition for their prey at night, right? So being nocturnal has its advantages. Whereas on the other side, the opposite is diurnal. If you have a look at most of our big animals over here, they tend to be more active during the day and at night less active. It doesn't mean that they're not, all right? Please, there's no just given law there that they're not. But generally speaking, nocturnal animals, all right, usually are more active at night, and my diurnal, all right, are going to be active during the day. And what did we say our physical factor was? Light. Light and temperature, all right, often coincide. They often mingle, but here we're just talking about the light intensity, okay? So what are the words you need to know? Photosynthesis, phototropism, moving towards the light, photoperiodism, a period in which the light, okay? What else? Nocturnal, diurnal. Right, all of those are really, really important. Let's go on to our next one. Temperature. Okay, temperature. When it comes to temperature, you are going to get very, very hot. You are going to get very, very cold. So those are our extremes. And then you're obviously going to get the moderate. Now, as a general rule, your largest biodiversity is going to be in the moderate. You're going to find less variety too hot and less variety too cold. But animals need to be able to adapt to the different temperatures. Okay, first thing. Now, what you also need to know, there's two words that I want you to put in, all right? And you're not allowed to say cold-blooded and warm-blooded anymore. It's endothermic. Endo means inside, and that is going to be your warm-blooded, all right? And ectothermic. Ecto means on the outside. Sorry, oh, I can't do that. Oh, all of that. Cold-blooded. There we go. And what it means is the environment, exothermic, all right, or ectothermic, what happens? The environment, all right, plays a role in their temperature. So now, if the environment is really hot or it's really cold, they might want to do something, all right, during those periods to be able to adapt to the heat. Okay, first one, I'm sure you know, hibernation, winter sleep. All right? And not only do ectothermic animals hibernate, but you're also going to find that some endothermic, well-known bears like to hibernate. All right? So what do? They sleep in winter. They're preserving their energy. Migration. Move, especially we look here at birds, they migrate. They move from one warm area and then spend what would be a winter in another area summer. So it's almost if they cut out the winter. They have summer and summer and summer and summer. So they miss out on the cold. They take the shortcut. Here's a term, all right, that I don't think many of you have heard of before. It's estivation. Estivation. And estivation means to burrow a hole, all right? All right, to burrow in warm, or actually hot, warm, dry conditions. Okay, so warm and dry. Not the cold. Cold is hibernation, warm and dry. So there's not enough, look here, my frog is an example. Not enough water. It might be too hot. There might not be enough water. His pond might have dried up. Buries a hole. As you go lower down in the ground, the sand becomes much cooler, all right? And with that cooler sand, then you're going to get much colder. You're not so hot at the top, and then you're able to control your temperature. Don't forget plants, all right? Plants also need to be able to find ways in which to survive the cold. Those of you, I'm sure, have heard of bulbs or tubers. Here's a daffodil over here. I just want you to see it will flower, all right? And then what will happen when it gets too cold, the top part will fall off, all right? The top part dies. But underneath the ground, when it's cold, all right, it will stay there as a bulb. So it also hibernates. It's like a plant hibernation. So it will stay there waiting for the next season. When the next season comes, and then it will flower. I thought we were ready for a break.
How much?
One more.
No, do
one
that.
more. One
do
more.
that.
Yes. Okay. The last one is deciduous. I'm sure you've all noticed, because we're in the season now where the trees lose their leaves. And they do that to store or to save energy. The leaves take up a lot of energy, a lot of water to photosynthesize. So when it gets colder, all right, they cut off all the supply, the leaf dies, and it falls to the ground, and the tree is then able to save energy. And when does it occur? During the winter months. Okay.
Ready?
Now we're ready.
Mindsetters will be right back after the break. Don't go anywhere. Welcome back, grade 10s. I hope you had a fantastic little break. But while we were sitting here, we were just discussing some of your questions. Keep posting. Don't forget, facebook.com/learnextra with an X. And I will be here for the whole hour with you on this fantastic show and Facebook page. So please get posting. Also take the Curio Challenge. I'm posting it on the page, and it's where you can actually test yourself, see what you know, and it's very good for your studies. So I hope you do take it. But right now we're doing ecosystems, and it's over to Cheryl. Please take it away.
Thanks, Megan. All right, we're carrying on with our abiotic factors, and remember, we're looking at our abiotic factors, and we're looking at how plants and animals need to adapt to that abiotic factor, which brings us to water. The next one is water. Water is not freely available. It's not distributed evenly. So if we're going to see that some plants, all right, are adapted to dry, some to more wet, and then obviously always the in-between. A plant that is adapted to water is a hydrophyte. Hydro means water. All right, so there you're going to see our water lily. So it's going to be different. It doesn't need to have any structures to prevent water loss. All right. Then our in-between is like the three little bears, too hot, too cold, just right. The mesophytes have sufficient water, and you're going to find the greatest biodiversity there because they have enough water. Then going on to our last one, our xerophytes. All right, zero as in very little water, and as you'll see over there as I put the cactus up, all your succulent plants, because they live in an area where there's limited amount of water, they need to have special adaptations. Very thick leaves, or their leaves are thorns. They've got a deep root system. Anything that they can do to store water, all right? They don't want to lose it easily. They want to store it because it is a very rare commodity. Animals also, all right, have to adapt to water. If you have a look over here for the crocodile, all right, it's got a nice tough skin. If most of your reptiles, scaly skin, and it's difficult. You can't lose water, all right, through that. So you have a retaining ability. Have a look at the camel here. This is the camel and this is the kangaroo rat. Now, both of those live in very dry areas. The camel, all right, stores a lot of its water, okay? So when it does get the chance to, it gets the water mostly through its food, but it's able to store a lot of its water. And actually, an interesting fact, if it does, its urine is usually crystals, all right? So it's not the usual water because the water it wants to keep. This little kangaroo rat over here doesn't drink any water. All of the water that it gets is through its food, okay? So they are adapted to a lack of water. Right, let's go on to our next characteristic, gases, all right? And what's gases? We looked at it as well when we looked at the biomes. Oxygen, carbon dioxide, and nitrogen. Okay, what do we, oxygen? Yes, plants, again, we're going to go with the photosynthesis. Plants take in carbon dioxide, which is a gas, and what do? They make oxygen, which is released. So they are very important in keeping the levels correct. Nitrogen. Okay, nitrogen, 78% of the Earth's atmosphere is nitrogen. Yet, us animals, all right, we are unable, all right, to breathe it in. If we breathe it in, it comes in and it goes out. We cannot use it. We are reliant, all right, on plants. Plants and the bacteria around the plants are in the soil. But that bacteria converts the nitrogen into what we call nitrates. Plants then can absorb those nitrates, okay? And then we eat it, or the cow eats it, or we eat the cow, and that's how we get nitrogen. But next week we're going to look at the nitrogen cycle in more detail. Obviously, some animals which are in water need to be able to have special breathing systems because they don't have lungs. There the fish has got gills. And as I say to you, all organisms, all right, just a few anaerobic bacteria that don't, all organisms need oxygen to live, all right? So here we go back to the photosynthesis. All living, all biotic components need oxygen to survive. No oxygen, no survival. Okay, let's go on to our next one. Wind. All right. Wind doesn't play as much of a role, but if you can have a look over here for this tree, all right, it does. Where does wind play a role? You did it at the beginning of the year, all right? We looked at transpiration. Transpiration, the loss of water vapor from the leaves. And what was one of the factors that increased transpiration? Wind, okay? So very, very windy areas, what are you going to find? Transpiration happens much quicker, so plants are losing more water. So you find that probably you don't have such a great biodiversity in areas that are very, very windy. What else happens, all right, during wind? Evaporation. What are we doing? Water is lost. And water is lost through our dams, our rivers, all right, and also we lose water. When it's windier, what happens? When we sweat and the heat evaporates much quicker, the sweat evaporates. And what happens? We tend to sweat more. And in doing so, we might dehydrate. And animals would also have this problem. So a lot of wind, all right, increase in transpiration, increase in evaporation, which actually translates to an increase in water loss. Okay, next one. Aha, our physiographic factors. Physiographic means a place's position on the earth, all right? The place's position on the earth. And we're going to be looking at the three factors: slope, all right, aspect, and altitude. Now, aspect, have a look at the diagram here. What aspect is, okay, is the position of the sun or position of an area in relation to the sun. This is the southern hemisphere, us. This is a north-facing slope. And look, what does it do? It gets direct sunlight. This is a south-facing slope. So we can almost say that this is in the shade, all right? Lots of sunlight, lots of shade. Now let's go back to our physical factors. If there's lots of sunlight, what do you think is going to happen on this slope? All right, yes, it's going to be hotter and it's going to be drier. All right, so what do we find? Organisms adapted to heat and to less water are going to be found on the north slope. The south slope, all right, because it's in the shade, is going to be cooler and wetter. So it's almost as if the climate is different. Okay, so we've got the one side hot and dry, so plants and animals adapted to that are going to be found. On my southern slope, cooler temperatures, plants that like shade, that need a lot more water. So you're actually probably going to find a greater variety of plants, which will then mean a greater variety of animals. Okay, so aspect is north-facing versus south-facing, right? Some of you ask your parents, you'll see sometimes when they build their houses, all right, they have certain rooms facing certain directions so they can have sun in the summer or some in the winter and a cooler in the summer. That's often how we, all right, some of the houses are planned that way, all right, using that characteristic called aspect. Okay. Sometimes you'll see on the movies they try to find direction. All right, if it's cooler, you might find moss, and then you know that's the south facing. If the tree trunk doesn't have anything, it's going to be warm, then it's going to be more north facing. So you could almost use it as a bit of a compass. Okay, so that's the first one. Second one is slope. Now, I couldn't find a nice picture, so I drew it myself.
It's good artwork
it's
there.
Fabulous, yes.
I think it's fantastic.
And simply what slope is, all right, this side is a gentle slope, and this side is a steep slope. Okay, now it's all got to do with how water runs off it. Okay, so if we have a very steep slope, water rushes down much quicker. And because it's got all this force and it's rushing down, what tends to happen? Erosion. All right? A lot of the soil is eroded, and then because there's not so much, all right, nice soil there, because it's all been washed away, you're going to find very few plants living on a steep slope. A gentle slope is different. What happens? The water gently flows, okay? And because the water is gently flowing, what happens? You don't have so much runoff, so you're going to have lots more plants. And if you've got lots more plants, you're going to have lots more animals. Okay, aspect, north versus south facing, slope, steep versus gentle. And our last one, all right, okay, is altitude. Altitude is height above sea level. Okay, so going back to my diagram, if this is an area of low altitude, and obviously here I am, a little mannequin waving at you, area of high altitude, we're going to find a difference. At the top, it is colder. it is windier, all right, and quite often you can find snow. So the temperature can be quite extreme. So what are we going to find there? Very little plant life and very little animal life. Not that there isn't any, but again, conditions could be quite severe, so we tend to have just small amounts. Whereas when we get to the bottom of the slope, what do we find? It's going to be warmer, all right, and the temperature is going to be far more, all right, neutral. Also, there's one other thing. The higher I go, oxygen, all right, we looked at this, all right, before. The higher I go, not that there's less oxygen, all right, there's just less of a concentration. So the higher you go, the less oxygen is available, all right, to you. So obviously, if the less oxygen is available, it's not as easy to live. So we're going to find a lot less animals, all right, or organisms living at very high altitudes, where at very low altitudes, there's plenty of oxygen available, all right. So it just basically influences our variety and what animals are able to adapt to those specific conditions. Okay. Edaphic, and I want to put over there if you have a look. Edaphic means soil, all right? And we look at when we look at soil, we separate them into 3 groups. Sand is our one side, on our one extreme. Clay is on our other extreme, and then our just right in the middle is called our loam. Okay, so when we look at it, we're going to see certain plants are going to prefer either one of the soils, all right? They all have their different characteristics, and certain plants are adapted to growing in the certain soils. One extreme sand, one extreme clay, and then, as I said, the just right one, the loam. But it's all depending on how the plants or animals, most specifically, is going to be the plants. Okay, so there you'll see sand, clay, and loam. They all consist of they all have parts of each other in it. If you have a look over here, sand, all right, has a bit of clay, a little bit of loam. They each have got little bits of each other, all right, but obviously the majority is of themselves. Now, when we look at it, it's very important. First thing, okay, is the pH of the soil. The soil's pH, that means is it acid or is it alkaline, will depend on what grows there. Certain plants, and I've showed you over here, our protea, likes a slightly acidic soil, all right? Whereas lucerne is what cows eat, it's like cow food, all right? Horse feed, it's quite a nutritious kind of grass. It prefers a much more, all right, alkaline soil. We also tend to find that where there's areas that are a lot more, with a lot more water, that's where you're going to find it's going to be far more acidic, because the water actually leaches all the minerals, all right? And it's the acid that remains. And in your drier areas, you're going to have a much more alkaline soil. So the pH of the soil affects what plants are going to grow there. Okay, next one. So that's the first one. Next one. Okay, before I carry on, James is whispering in my ear for an ad break.
That is our director. Okay. Well, you heard it straight from James himself. So, right after the ad break, we'll be back. Don't go anywhere. Welcome back, grade 10s. I hope you had a fantastic ad break and now you are refreshed and ready to get on, because we are almost finished. I just want to say hello to our director, James, Wilson, and Abraham, because if you guys don't ask me to say a shout out to you, then I can only give a shout out to my crew here at the Mindset Studio. So thank you for working so hard, our Mindset team. And I'm just going to carry on with the show, because We have a lot to get through, so let me just ask you a question.
Okay. Yes.
Daniel, who's always with us, thank you, Daniel, says, can you please tell me what causes a wetland?
A wetland, you weren't tuning in last week, Daniel.
Daniel.
All right.
Naughty.
A wetland, all right, is a natural phenomenon. It's a biome, all right, and it's an area that, I won't say it's waterlogged, of natural inland water, all right, where we find, it's, as I said, it's a biome. It's a natural area that occurs, and wetlands are very, very important. They filter our water, they help fill our water table, and they are a treasure of our countries, and we mustn't.
Okay,
hold
and one
there.
more just
Yes.
before we carry on. Leba, I hope I said it right. Please excuse me. What's the meaning of the term biota?
Biota.
Yeah, B-I-O-T-A. Am I right?
No.
Sorry, Leba.
Biotic, yes, not biota.
I don't know.
Okay.
Sorry, we couldn't help you.
We'll go and check and see. Maybe
Yeah.
there's a meaning that you know and we don't know.
Yeah.
All right, let's carry on. We're busy with soil. And I know there's a lot of writing, but pay more attention to the pictures, okay? The first thing we're going to look at, after we did pH, all right, now we're going to have a look at the texture. I want you when you pick it up with your hands, you will see that the size of the particles, if you have a look on the diagram here, sand is large, all right, clay is very, very small, and again, our little baby bear in the middle, loam is medium sized. Now, the size of the particles is going to be important in two things, all right? Water retention, how much water it keeps, and how much air is in the soil. Because remember, let's go back. What do all living things need? They need oxygen and they need water, okay? And plants are going to get that from the soil. Now, the texture, the larger one, much more gritty, all right? If you touch it, it's quite coarse. The clay is very, very fine, and whereas the loam in the middle again, all right, a bit of a floury taste. There might be a few coarse particles, but generally quite floury, as in the flour that we use to bake with. Now that is going to have an effect on our next one. Okay, I'm going to draw pictures. Water retention and aeration. If you have a look here, all right, I'm going to draw it as well. Let's have a look at the sand here. Because the particles are much bigger, okay, they are going to have lots of spaces in between them. Now, those spaces are going to be storage spaces. First of all, those little spaces can store oxygen, all right? So they're going to have air. So it's well aerated. That's what we mean. It can hold a lot of oxygen, a lot of air. Okay, but on the other hand, those large spaces means that water goes right through. Those large spaces don't hold a lot of water. The water actually goes all the way down. So it has a very poor water retention, okay? And with that, the water going away, it erodes easily, all right? Also, it leaches all the nutrients in the soil because they're washed away, actually leaches the nutrients and not always very fertile. Let's go. So what's one side? Let's go to the other. Have a look at our clay. All right? The clay are very, very, very small particles. So what does that mean? One, very small spaces, almost non-existent. So air, very small spaces, non-existent, very little oxygen. So poor aeration, okay? Poor aeration, not a lot of air in it. And now because those particles are so small, it holds all of the water. If you if you take clay, you can actually make little mud pies and, because it's going to stick together. The water stays in there. So clay has got good, all right, water retention, but it's not always so good because water can become very blocked there, and plants battle to this. It's got too much acid in it, all right, and not enough plants can grow there. You'll find quite often it lacks nitrogen, so plants not always, all right, a great area for biodiversity. Poor aeration but very good water retention. Now we go to our little baby bear, all right, the loam. The loam's particles, right, it's the same as silt over here, okay, are medium sized. So what do we find? We've got nice air pockets that holds air, so we've got good aeration, and because our spaces, our air, the parts in between the particles are not too big, it actually can hold water. All right? So because of that, it has good aeration and it has good water retention. And that's why much more, all right, you're going to find much more variety of plants in your loam. It's also usually neutral in its pH, and most of the plants do prefer a neutral pH. The next one, all right, is we're now going to look at our biotic factors. Okay, now the biotic are the living, and I'm sure you have done these ones, all right, since you were in primary school, you've looked at the words. So now we've finished with our abiotic. Remember, we looked at physical, we looked, which was our light, our temperature, our water, our wind, all right. We looked at our physiographic, which was our slope, our aspect, and our altitude. Then we looked at our edaphic factors, which was our soil, all right, water, could it hold water, could it have air, what was the pH, is there lots of humus, the mineral contents that are in the soil, all right, and now we're going on to our biotic components. Okay, biotic components are divided into two groups, right? The first one we call the autotrophs. All right, the autotrophs. And those are, it's another word for producers, which is another word for our green plants. Auto, automatic, trophs, level. Green plants, what can they do? Are able to photosynthesize and make their own food. They are not reliant on something else to photosynthesize. That was a characteristic of the plant kingdom. All right, so autotrophs, they are able to make their own food by the process of photosynthesis. And as you can see here, got a nice little forest, and this little thing that you're going to be doing next year, all right, the actual process of photosynthesis. What do I need? Look there, sunlight, carbon dioxide, water. What do I make? What happens here? Plants, what do they need? My abiotic factors. If they don't have these, they cannot photosynthesize. And they make food for the next group, called my heterotrophs. All right? Heterotrophs cannot make their own food. They need to get it some other way, obviously, usually by eating. Okay? Now, because they eat, we call this group the consumers. So my producers produce the food, all right? My consumers are going to eat the food. So if you have a look there, all right, again, the word that I want you to know, heterotroph. Plants, autotrophic, consumers are heterotrophic. Okay, now let's start. We take our consumers, you know, as biologists love to put things into groups. We take our consumers and we divide them into groups according to what they eat. Okay, I'm sure you can gather which the first one is. And you need to know this because next week when we look at food chains and food webs, and you need to be able to know which is a producer, which is a consumer, so we can fit them into the different trophic levels. Okay, when we talk about eating here. All right, here's a lion attacking the buffalo. Here's a worm eating an apple. All right, I think it's a tomato. And here is us having nice, healthy salad for supper. That is, we gain our food. All of these are eating. All right, they are all eating because we cannot. It would be lacquer if we could lie in the sun and whoo, there we go, breakfast. But it's not going to happen. Okay, we get our energy from the food that we eat, which the plants have made. So yes, let's see herbivores. All right, herbivores. Herbivores only eat plants. All right, herbivores will only eat plants. Go for the ones that are most obvious. I've put in there cow, sheep, buck, but sometimes you also just need to be able to. Here's a nice little hoho eating, all right, and a leaf. Our rabbits are also herbivorous. They nibble on grass and nibble on carrots. Right, and I put this picture in there because it's my favorite animal. Right, it's a giraffe, and it's going to be eating the leaves from the trees. So all three of those things, what they have in common, they just eat plant matter. Okay, so first one, our herbivores. I'm sure you can gather which one the next is. They only eat meat.
Like
yes.
us.
Hey?
I said like us.
Yeah, no, I don't like my
Almost.
green vegetables, so I think my mother says to me sometimes.
Sometimes I
of a
think I'm
carnivore.
just a carnivore. All I eat is meat. So.
All right, carnivores. It says they eat other animals. That it is what they do. We eat meat. All right, they just eat meat. Their diet is very much involved. Here's my lion again. All right, feeding on a carcass. Here's a poor seal that becomes prey. All right, to a shark. And if you have a look over there, I like this one. There's a poor grasshopper, and it's going to become the frog's meal. All right, so all of those are our carnivores. Right, they eat meat. Now we get to the next one, which eats meat and plant matter. Yes, you are quite right. Those are the omnivores. And this is where we fit in. Right, even if you're a vegetarian, you are an omnivore, all right, because you eat eggs from animals and cheese and stuff like that, milk, all right. Those are all part of animal products, unless, of course, you're a vegan. And then, well done to you.
Yeah.
I could never be one.
Definitely not me.
I always have a saying that green is gross, but unfortunately, it's not always the healthy way to go. Okay, guys, here, omnivores eat both plant and animal matter. Humans, pigs, bears. Also here, I put in, all right, our little monkey over there eating. He's eating a green leaf here, but they also, all right, do have a variation diet where they will eat meat products. An ostrich will pretty much eat anything, all right?
Ostriches are special creatures.
Ostriches are very special creatures, all right? They will pretty much eat anything, and they are omnivorous, okay? Dogs are also omnivorous because we have, all right, tamed them, they've become our pets, but you'll find hunting dogs, all right, and wild dogs, they are going to be carnivorous, so we need to make a bit of a distinction there. Then you get those lazy, I call them lazy, all right, the scavengers that wait for another animal to do the hard work, and there they come in, all right, and they don't actually do the hunting themselves. They can, right, but generally they wait for somebody else to do the work, and as a scavenger does, and then come in and steal the carcass or feed off the leftovers. Our examples here are hyenas, all right, hyenas are scavengers, and obviously, if you'll see over here, are vultures. Okay, so we have producers, we have our consumers. Producers make, consumers eat. All living things are going to die, all right? It's one of those things in life. What needs to happen? You now need to break down all of that organic matter and return the nutrients to the soil, all right? And that is what decomposers do. Decomposers are your bacteria and your fungi. All right, they do not have, again, they cannot make their own food. They live on dead organic matter. Bacteria as well has many functions, but one of its things, when anything dies, be it plant or animal, it breaks it down and returns that organic, remember you did biochemistry, organic, carbon, hydrogen, oxygen, nitrogen, all of that, all right, needs to be returned to the soil. Okay, we need to continue the flow, all right, of our nutrients. They are called saprophytes. Okay, another word for decomposers is saprophytes, and you'll see I like to eat when I love mushrooms, all right, and they're bacteria, all right, all nice and healthy and breaking things down. Are we finished for tonight? Because there we go.
Is that all you have?
That's it. Yeah.
Okay.
That's all we have time for.
Oh, Cheryl. Well, grade 10s, it's been a fabulous show. I've really enjoyed speaking to all of you on the page. Cheryl's really enjoyed answering all of your questions. We've had a fantastic Women's Wednesday here on Life Sciences. We want to say thank you. Have a fantastic afternoon. I just feel like a nana now. But we'll see you same time, same place next week. Learn more, learn extra. Cheers, guys.